Hello. In this video, we're covering section 1.2. It's a continuation of 1.1. In 1.1, we covered linear equations. So in this section, we're doing linear applications and modeling. So we're going to be doing some word problems. So one of the main reasons for learning mathematics is to be able to use it to solve application problems. While there is no one method that enables us to solve all types of applied problems, the following 6 steps provide a useful guide. Okay, step number 1, read the problem carefully until you understand what is given and what is to be found. Number 2, assign a variable to represent the unknown value using diagrams or tables as needed. And number 3, write an equation using the variable expressions. Number 4, solve the equation. 5, state the answer in terms of the problem. And 6, check the answer in the words of the original problem. So we're going to do example 1. We're going to use a geometric formula. This is on page CA 94. If the length of each side of a square is increased by 3 centimeters, the perimeter of the new square is 40 centimeters more than twice the length of each side of the original square. Okay, so let's call X. So let's say we have a square. So all sides are equal. And the variable is going to be X. This X represents the length of each side. Of the original square. Now, the length of each side is increased by 3 centimeters. So now the length of each side is going to be X plus 3. Okay, and the perimeter of the new square is 4 centimeters more than twice the length of each side of the original square. So the perimeter of the original square is 4x. And the perimeter of the new square is going to be 4 times x plus 3. So the perimeter of the new square is 40 centimeters more than twice the length of each side of the original square. That is, the perimeter of the new square is 4 times x plus 3. And then twice the length of each side is going to be 2x. Twice the length of each side of the original square is 2x plus 40. We're going to find the dimensions of the original square. That is, we are going to solve for x. Okay, so solve this equation for x. We're going to distribute the 4. So we work with this type of equations. And then, you know how this goes. Subtract 2x from both sides. So 4x minus 2x is going to be 2x. And subtract 12 from both sides. 40 minus 12 is going to be 28. And finally, divide by 2, and x is going to be 14. So the original square measures 14 centimeters. And that's it. So this problem, this was a geometry problem, and it involved the perimeter of a square. The next one is going to be a three-dimensional object. We are going to use the surface area of a rectangular box. Okay, so this involves the volume. And surface area of a rectangular box. So let's say we have a rectangular box with a given length, width, and height. So it has a given length, width, and height. The volume, we're not going to use the volume in this section, is the product of the length times the width times the height. And the surface area it's going to be S. That's the sum of each of the sides of the square. Or not the sides, it's each of the faces. So the top and bottom, from this perspective, the top and bottom, the area of the top and bottom are both length times width. So that's going to be 2 times length times width. The front and back, if we see them from this, if we see the square from, if we see the box from this view, the front and back would be both length times height. And the left and right sides are both width times height. We have 2 of those. So that's the formula for the surface area. So I'm not going to be writing CA all the time. So I'm just going to refer to the page number, but we're always working with the second book. We're going to use the surface area formula to answer this question. And that's on page 101. A storage bin is in the shape of a rectangular box. Find the height of the box. If the length is 18 feet, its width is 8 feet, and its surface area is 496 square feet. So usually, from the question of the problem, we are going to determine the variable. In the first example, the problem was asking for the length for the dimensions of the original square, and that is going to be the variable. In the second example, they are asking you for the height of the box, so that's going to be the variable. So let h be the height. We also know that the length is 18 feet. The width is 8 feet. And the surface area, we have the formula above. The surface area is 496 square feet. Okay, so let's put everything together. We know that the surface area is 496. And we know the length and the width. So 2 times length times width plus, so that one is 8, plus 2 times length times height plus 2 times width times height is 496. We're going to solve this equation for h. Okay, so 2 times 18 times 8 is 288. Two times 18 is 36, and 2 times 8 is 16. Okay, so subtract 288 from both sides and combine 36 plus 16. So these two together are 52h. And 496 minus 288 is going to be 208. Divide both sides by 52, and the height is going to be 4. So writing the answer in terms of the problem, the height of the box is 4 feet. Or the height of the bin. The height is 4 feet. Okay, so the first two problems were geometry problems. We're going to do applications to motion problems. So that's going to be the next type of application. It's going to be on motion problems. So motion problems, when they ask you the height, how long does it take, how far is the distance, what is the velocity, you're going to use the formula R equals D over T. Where R is the rate or velocity, or the speed. In more advanced physics, velocity and speed are not the same thing, but for now we're going to think of them as the same thing. This is the distance traveled, and this is the time elapsed. So velocity is distance over time. We can write that, so we can write this in different ways. Velocity is distance over time, or time is, or distance is velocity times time, or time is distance over velocity. So we can solve this formula for any of the variables. We're going to look at number 20 on page 101. Actually, they give you a chart, but I'll show you where this chart is coming from. You have a table that you're going to fill. So that's still on page 101. Elwin averaged 50 miles per hour, traveling from Denver to Minneapolis. Returning by a different route that covered the same number of miles, he averaged 55 miles per hour. What is the distance between the two cities to the nearest 10 miles if his total traveling time was 32 hours? Okay, so the book has this table for the going and for the returning trip. So you need 3 variables: the velocity, the time, and the distance. So on the going trip, Elwin averaged 50 miles per hour. We're going to call X the time from Denver to Minneapolis. Okay, so let's write the variables on the side. Okay, so he averaged, and on the returning trip, he averaged 55 miles per hour. We are going to call X. Let X be the distance from Denver to Minneapolis. Okay, so no, sorry, not the distance, the time. The travel time from Denver to Minneapolis. So we're going to call this X. The total traveling time was 32 hours. So from if the time from Denver to Minneapolis was X, from Minneapolis to Denver was 32 minus X. And the distance, we can see above that the distance is velocity times time. So 50X, the distance is either 50X on the going trip. It says that the route covered the same number of miles. The distance is either 50X or 55 times 32 minus X. So in the book, they give you this table. And actually, I finished the table, but the problem comes with this table already. That 32 is because the total travel time was 32 hours. So X from Denver to Minneapolis and 32 minus X from Minneapolis to Denver. Okay, so we are going to solve. If it covered the same number of miles, we are going to solve 55 times 32 minus X equals 50X. Yeah, well, I'm just going to change the order. Doesn't matter that much. I'm just going to change the order, 50X. Equals 55 times 32 minus X. So if X is the travel time from Denver to Minneapolis, Y is Minneapolis to Denver. X plus Y is 32. So Y is 32 minus X. This is where 32 minus X is coming from. Okay, so we're going to solve this for X. And that is going to give us the time from Denver to Minneapolis. So this was 50X. This is a 50. So let's solve this equation. 50X equals 50 times 32 is 1,760 minus 55X. And then add 55X to both sides. So 105X equals 1,760. Divide both sides by X. So X is 1760 over 105. Or if you simplify the fraction, you reduce the fraction, that's 352 over 21 hours. So we found the travel time from Denver to Minneapolis, but we're not done yet because we want to find the distance. They are asking us for the distance between the two cities, and the distance is going to be If we found x, the distance is going to be 50x. That's 50x, or 50 times 352 over 21. To the nearest mile, that's going to be approximately 840 miles. That's the distance between the cities. So I'm going to do another example involving motion. But just wanted to show you something. Let's see if I can, if I can show you this. Yeah, I'm just going to show you on Google Maps. How accurate is this? So according to Google Maps, the fastest route takes 940 miles, but there are some other options. Like according to this route, so this route says that, okay, so we can see it. Yeah, so we found that is 843. According to Google Maps, there's a route that is 843 miles. So yeah, this problem is realistic. But I'm going to do another problem involving motion. That's on page 102, number 27. Number 27 on page 102. Okay, Callie took 20 minutes to drive her boat upstream to water ski at her favorite spot. Coming back later in the day at the same boat speed took her 15 minutes. If the current in that part of the river is 5 kilometers per hour, what was her boat speed? So that's all we know. Now be careful because the times are in minutes, but the velocity is in kilometers per hour. So we need to make sure that we write in the correct units. So we have, again, we're going to make a table with the going and the returning trip. A table with distance, time, or with velocity, distance, and time, or velocity, time, and distance. So we don't know what the velocity is, but they are asking us what was her boat speed. So let x be the boat speed. We can also see from the context that Callie took 20 minutes to drive her boat upstream, and coming back, it took her 15 minutes. So the returning trip was shorter, even though the boat speed was the same. And that's because on the going trip, actually it took her, on the going trip, she was going against the current, and in the returning trip, she was with the current. Against the current, that's going to be x minus 5, and with the current, the velocity is x plus 5. The times were 20 minutes. The going trip was 20 minutes, and the return trip was 15 minutes. Now, I'm not going to multiply just yet because the velocity is 5 kilometers per hour, and we must have everything with the same units. but that's not much of a problem. 20 minutes. If we want to convert this to hours, this is 20 out of 60 minutes, or 1/3 of an hour. And 15 minutes, you know that is a quarter hour. Okay, so the times are going to be 1/3 and 1/4. And the distances are 1/3 x minus 5, either 1/3 x minus 5 or 1/4 x plus 5. So all we need to do to find the boat speed is solve, make the distances equal because the distances are the same. So we need to solve 1/3 x minus 5 equals 1/4 x plus 5 for x. Okay, so we set up the problem. Now we need to solve it. And x is going to be the boat speed, so that's all we need to find. Now we have a problem with fractions. You want to avoid fractions, that's not much of a problem. We're just going to cross multiply. So cross multiply the 3 and the 4, and 4 times x minus 5 equals 3 times x plus 5. All I did was cross multiply. And then subtract 3x from both sides. So 4x minus 3x is x. And 15 plus 20 is 35. So her boat speed was 35 miles per hour. Sorry, not miles, kilometers per hour. Okay, so we did a couple of geometry problems and a couple of motion problems. So I'm going to do an example with mixtures, and I'm going to finish the section with 2 examples with investors. So the next situation is mixtures. Problems involving mixtures of 2 types of the same substance, salt solution, candy, and so on, often involve percentages. So in mixture problems involving solutions, the rate of concentration, the rate or percent of concentration times the quantity is going to be the amount of pure substance present. So let's say some solution of 100 milliliters has 40% of alcohol, then it has 40 milliliters of alcohol. So this is going to be the key. The percent of concentration times the quantity is going to be equal to the amount of pure substance present. Let's do example 3 on page 97. A chemist needs a 20% solution of alcohol. She has a 15% solution on hand, as well as a 30% solution. So she's going to add the 15% solution into the 30% solution to get a 20% solution. So question, how many liters of the 15% solution should she add to 3 liters of the 30% solution to obtain the 20% solution? So let X be the amount of liters of the 15% solution that will be added to the 30% solution. Okay, so we have 3 variables involved. We have the percent of concentration, the quantity, and the amount of pure substance present. Okay, so let's do that. We have the strength of the solution. The strength, that is the percent of concentration. Okay, so we have the percent of concentration. We have the quantity of solution. The quantity of solution. And we have the quantity of pure alcohol. Okay, so let's do that, the quantity of pure alcohol. And remember, we're working with percents. When we do the arithmetic, when we do the math, we need to convert the percent to decimal. So the 15% solution, we actually want to know how much do we need to add. Okay, so it's going to be X liters of the 15% solution. And then we have 3 liters of the 30% solution. So whenever we mix the solutions, the quantity is going to be X plus 3. And we're adding, well, we want to obtain a solution that contains 20% alcohol. So anything else? Okay, so the quantity of pure alcohol is going to be 15% of X on the first solution. The quantity of pure alcohol in the 30% solution is going to be 0.3 times 3. Or 0.9. And the quantity of pure alcohol in the 20% solution is going to be 0.2 times X plus 3. So if we are mixing the solutions, we are going to obtain, we're mixing the 15% solution, or we are adding the 50% solution to the 30% solution. And that's going to be 0.2 times X plus 3. We are going to solve this for X. Okay, so let's do that. We're going to distribute on the right-hand side. So this is 0.2x plus 0 point plus 6. Let's see, plus is not plus 6, it's plus sorry, that's 0.6. 0.6. Actually, that's 6. I see what mistake I'm making. Yeah, I'm adding a 0, so that's 0.6. So I was adding an extra 0. Okay, so you know how it goes from here. Subtract 0.2x from 0.15x, and that's going to be minus 0.05x. And subtract 0.9 from 0.6, that's going to be minus 0.3. Divide both sides by 0.0 by minus 0.005, and that's going to be 6. So 6 liters of the 15% solution must be mixed with the 3 liters of the 30% solution. So this one should be mixed with the 3 liters of the 30% solution in order to obtain a 20% solution. Okay, so the last two examples involve investment, and we're going to use the formula that I mentioned. Okay, so we are going to use the formula I equals PRT. So I mentioned this in the last section. I is interest. P is the principal or initial deposit. R is the interest rate. And T is the years after initial investment. So that's going to be time in years. Okay, we're doing number 36 on page 103. And actually, they give you already the table, but I'll explain you where this table is coming from. Okay, Roger bought 2 plots of land for a total of 120,000. When he sold the first plot, he made a profit of 15%. When he sold the second, he lost 10%. His total profit was 5,500. How much did he pay for each piece of land? Okay, so let X be the price of the first plot. Okay, so X is the first price of the second plot, and he bought 2 plots of land for a total of 120,000. That means 120,000 minus X is the price of the second plot. Okay, the rate of return was 15%, and in the second one he lost 10%. Okay, so we have the land price. The land price, the rate of return, as a percent, and the profit or loss. Okay, so the land price was X for the first plot, and 120,000 minus X for the second plot. The rate of return was 15% on the first plot and 10% on the second plot. And so he made profit from the first plot, but he lost money from the second one. We know that the total profit okay, so that was a profit. So I'm going to do this. That was a profit, so that was 0.15x. And the loss, if this was negative, that's 0.10 times 120,000 minus X. Okay, the total profit was 5,500. And adding the two together, 0.15x minus 0.10 times 120,000 minus X must be equal to 5,500. We are going to solve this for X. Okay, so that's going to be what? That's going to be 0.15x minus 12,000 plus 0.10x. So 0.15x plus 0.10x, that's going to be 0.25x. 55,000 plus 12,000 is going to be 1,000. This is going to be 17,500. Divide both sides by 0.25, or another way to say is multiply them by 4, and X is going to be 70,000. And 120,000 minus X, it's 50,000. The questions were how much did he pay for each piece of land. So he paid 70,000 for the first plot and 50,000 for the second plot. And I'm going to do one more example with investments. Okay, same page 103. A church building fund has invested some money in 2 ways. Part of the money at 3% interest and 4 times as much at 2.75% interest. Find the amount invested at each rate if the total annual income from interest is 2,800. So we're going to call X the amount invested at 3%. And 4 times as much was invested as 2.75%. So 4x is going to be the amount invested at 2.75%. The total interest. So I said that the total annual income from interest was 2,800. So the total interest is 3% invested at X dollars invested at 3%. That's going to be 0.03 times X. And 4 times X dollars invested at 2.75%. That's going to be 0.0275 times 4X. That is 2,800. Now, 4x times 0.0275 is 0.11x. Well, I shouldn't write equal. So 0.03x plus 0.11x is 2,800. Or 0.14x is 2,800. Divide both sides by 0.14. And x is 20,000. And for x is 80,000. So finally, a total of 20%. So a total of 20,000 was invested at 3%. And 80,000 was invested at 2.75%. Thank you for listening.